Hi everyone, this is Math 132, Section 22. Before we start, just a few reminders. Don't forget that you have a homework 3.4 that's due on Friday, and then the next one, 3.5, is due on next Wednesday. Today I want to finish up 3.4, and then we will also start a new section, Section 3.5. What we did last time was we talked about vertical asymptotes and also the horizontal asymptotes. Remember that vertical asymptotes is always they always look like x equals something, horizontal y equals something, and make sure you go review the notes because I don't want to put down the definitions again. One example that we did last time and I didn't finish last time was this one. So this is a little bit different than what we did last time. So last time we had a negative sign here, but I kind of realized that it makes more sense if this is a plus. So let's just say that this is a plus. So now the question is, I want to compute the limit of that thing when x approaches negative infinity. Now, what do we do whenever we see a limit that involves a square root? We multiply by the conjugate. In this case, the conjugate is the square root of 4x squared minus 2x minus 2x, and then we'll do that to the top as well. And so you multiply this to the top, and by using the formula a squared minus b squared, you should get 4x squared minus 2x minus 2x squared. And then the bottom becomes square root of 4x squared minus 2x minus 2x. All right. For the top, we can simplify a bit. So for 2x squared is 4x squared. And then you can cancel out the 4x squared. So the top simplifies to 2x, negative 2x. The bottom becomes, well, it's still the same. And then last time I mentioned that because the top and bottom, they both have the variables x, one thing you should do is you divide by x. So you multiply the top by 1 over x, you multiply the bottom by 1 over x. Now, x times 1 over x becomes just 1, so the top becomes negative 2. The bottom, you have this. And then 2x, again, 2x multiplied by 1 over x, you get 2. And then the next step is I want to put this x inside the square root. Now, whenever you want to put a number inside the square root, what you do is you square the number first. So you square it like this, and then you put it under the square root. And this is still negative 2. Now, notice that we're taking x to negative infinity. So in particular, x is a negative number. Whenever you put a negative number inside the square root, you square it, but you also need to put a negative sign here. Let me say this again. If x is a negative number, whenever you put something, you put a negative number inside the square root, you should put a negative outside of the square root. If it's positive, you do the same thing here. So you square it and put it inside the square root, then this would be a plus. Now, what's next? This is a fraction, 4x squared minus 2x divided by x squared. I can split them into two parts. I have 4x squared divided by x squared. I have 2x divided by x squared. So 4x squared divided by x squared, I get 4. 2x divided by x squared, I get negative 2 over x. And then you still have the minus 2. And now you can put in the negative infinity. So what happens when you put negative infinity into the denominator here? You get 0. So this guy becomes 0. So you have negative 2 on top divided by negative root 4 minus 2. And so you have negative 2 divided by the square root of 4 is 2, so you have negative 2 minus 2. So you have negative 2 divided by negative 4, which ends up with, and you end up with 1/2. All right, let's move on to the, yeah, I probably should do one vertical asymptotes and horizontal asymptotes question. So here's one. Consider the function the square root of 2x squared plus 1 divided by 3x minus 5. Now the question is, find all the vertical asymptotes and horizontal asymptotes. Alright, so how do we find vertical asymptotes again? So you look at the original function and you see what is the x value that a function is not defined. You can see right away that the function is not defined when the bottom is 0. So 3x minus 5 equals 0. And if I simplify that, you get 5 over 3. And so this would be the vertical asymptote. And there's only one vertical asymptote. Now, it's not necessary to do it now, but it's going to be helpful later, so I'm going to do it here. So I want to also to compute the limit approaching 5/3 from the left and also from the right. Okay, so the first one is the left-hand limit. Now, looking at the original function, and I'm approaching 5/3 from the left, which means the bottom should be negative. It might not be obvious, but you should check that. So if you pick a number slightly smaller than 5/3, 3x minus 5 should be negative. And the square root is always positive, so positive, negative, you get a negative number. And this one, well, because it's a vertical asymptote, it should be infinity, so negative infinity. Now do the same trick for the second for the right-hand function, the right-hand limit. Pick a number slightly bigger than 5/3, and then you plug that into the bottom. You get a positive number, and again, this one should be positive infinity. All right, so, and then we go on and find the horizontal asymptotes. So we need to compute two limits. The first one is, I want to compute what happens when x approaches positive infinity. And the second limit is, I want to compute what happens when x approaches negative infinity. Okay. Right, let's compute the first one. Right, so let me put in a function, 2x squared plus 1, and then 3x minus 5. I'm going to do the same trick here, because the top and bottom, they both contain the variable x. I want to multiply the top and bottom by 1 over x. Well, okay, so it really depends on what variables you have. So the highest power of x for the top and bottom is x. So I multiply by 1 over x. Now the bottom becomes 3. So 3x multiplied by 1 over x, you get 3. 5 multiplied by 1 over x, you get 5 over x. The top, you have 2x squared plus 1 divided by x. Now, this looks like something that we did earlier. So the next step would be, I want to put x inside the square root. Now, what are we gonna do? What do we do when we want to put x inside the square root? We square it. So you put it under the square root, but you need to square it like this. And notice that because x is approaching positive infinity, this one should be positive. Let me say this again. When you put a positive number inside the square root, you square it, and then this is positive. Now, 2x squared plus 1 divided by x squared, I can split that into two terms. I have 2x squared divided by x squared. I also have 1 over x squared. So I have 2 plus 1 over x squared. Now you can take everything to infinity. So when you put infinity into 1 over x squared, this becomes 0. This becomes 0 as well. So end up with the top is just root 2. The bottom is just 3. And so get root 2 divided by 3. Now, the second limit is I also need to compute what happens when x approaches negative infinity. Now, the trick is still the same. So I'm going to multiply the top and bottom by 1 over x and get to this. And then I'm going to put x inside the square root. And to put x inside the square root, I need to square it. So I would get a term, something that looks like this. But now, because x is a negative number, when I put x inside the square root, I should put a negative sign here. And so everything is the same. So split that into two parts. You have 2x squared divided by x squared. You also have 1 over x squared. And now you can put, that should be negative. So now you can put negative infinity. Again, when you put negative infinity into 1 over x squared, this becomes 0. This also becomes 0. So you end up with negative root 2 over 3. Alright, now we just have to write down what is a horizontal asymptote. So there are two horizontal asymptotes. One is y equals that. The second one is y equals negative that. And that's it. Once again, vertical asymptotes. There's only one vertical asymptote, which is x equals 5/3. There are two horizontal asymptotes. One is y equals root 2 over 3. The second one is y equals negative root 2 over 3. Okay. Um, Another type of question that you can get is something like this. So you can get polynomial, and then maybe I'll ask you what is the limit when x approaches either positive infinity or negative infinity. I'm pretty sure we mentioned this couple lectures ago, but let's do one example. Okay, so I want to compute the limit of 3x squared plus 5x plus 6 divided by negative 7x squared minus 5 when x approaches positive infinity. Alright, so what you do is you only look at the highest degree term. So for the top, the highest degree term is x squared, and at the bottom, the highest degree term is negative 7x squared. So computing that limit is the same as computing the limit of 3x squared divided by negative x squared. Cancel out the x squared, you get 3 over negative 7, and then you are done. Okay. Alright, I think that's all we have for section 3.4. And now let's do the next section, section 3.5. So this is a section where things get much more complicated. But before we do some actual curve sketching, let's talk about one more thing. So actually two more things. So we talk about slant asymptote. Maybe I should write. So we had vertical asymptote. We did this before. And then we also did horizontal asymptote. And then there's this kind of asymptote that's called slant asymptote. And what is it? It's just a diagonal line. Let me write this down. So we say that a diagonal line y equals mx plus b. So that's a line equation, y equals mx plus b. And that can be approached by the graph f of x. So that means, in particular, that means when x approaches either positive infinity or negative infinity, the line y equals mx plus b and the function f of x get closer and closer. We'll see in a minute what this means. Okay, now how do we find slant asymptote? So we find slant asymptote by doing the long division. Okay, I'm assuming not everyone remembers what long division is, so let's do one example. Okay, so you have a function f of x equals x cubed divided by x squared minus 3. Whenever you have a function so that the top has higher degree than the bottom, you can always do the long division. So let me say this again. Whenever the top has the same degree as the bottom, or it has higher degree than the bottom, you can always do the long division. So the way you do it is you put the top inside this roof thing, and then the bottom you put it here. So I have x squared minus 3. It's missing the x term, so I'm going to put a 0 in the middle. So I have square, and then the x term is 0, and then the constant is -3. And then I'm gonna put something here. So the number, the thing that I'm gonna put here is so that when I multiply by x squared, I get x cubed. So what is the thing that when I multiply by x squared, I get x cubed? It's x. X times x squared is x cubed. X times 0 is 0. X times -3, I get -3x. And then you subtract. So x cubed minus x cubed, you get 0. 0 minus 0, you get 0. 0 minus -3x, you get positive 3x. Okay, now when do we stop the long division? We stop when the remainder has lower degree than this guy here. This guy has degree 1, this guy has degree 2, so we stop. And then we write, so the original function can be rewritten as this x plus 3x, which is the remainder, so remainder is 3x divided by that. Oops. Now, this function right here would be your slant asymptote. So the slant asymptote for f of x is y equals x. All right. The next thing I want to do is to talk about odd and even functions. Okay, so the function is odd if whenever you put the negative x inside your function, you get negative f of x. And yeah, so some examples are like this. You also have, the sine function. So sine of x is an odd function. We said that if a function is even whenever when you put in negative x, you get still the same as f of x. So a parabola would be an even function. cosine of x will be even as well. Okay. All right, to finish up, I'm going to do one example, but this is going to be a really big example. So I'll give you one function, and then we'll find what is a domain. We'll find out what is a x-intercept, what is a y-intercept, and then we find out what is a horizontal, vertical, and slant asymptotes. And then we'll find what are the local max, what are the local min, what are the inflection points, and the last step is to draw, to sketch the graph. So, this is the function we have. And I'll let you verify that, but you can check that the first derivative is this. And then you can also check that the second derivative is this. I think this is, yeah, this is cube. Okay. Now let's go ahead and write down what is the domain. Now, what is the domain? What are the only x values that I'm not allowed to put in? So the function is not defined when the bottom is 0, right? So when you set x squared minus 3 to be 0, you get x squared equals 3. And so you get x equals plus or minus root 3. And those are the only 2 points that you're not allowed to put into your function. And so domain is negative infinity to negative root 3, union negative root 3 to root 3, and then union root 3 to infinity. Okay. Now let's figure out what is the x-intercept. Remember that x-intercept is where y equals 0. So I need to set the y coordinate to be 0, which means I'm solving for x cubed divided by x squared minus 3 equals 0, because that's the original function, which is your y. So x cubed divided by x squared minus 3 equals 0. The only way for a fraction to be 0 is when the top is 0. So I get x cubed equals 0, which is the same as saying x equals 0. And so the only x-intercept is x-intercept is 0, 0, which is the origin. For y-intercept, you set x equals 0. Now, the original function was x cubed divided by x squared minus 3. So when you set x to be 0, you get y equals 0. So your x-intercept turns out to be your y-intercept as well. Alright. The next thing is to find out what are the horizontal asymptotes, vertical asymptotes, and slant asymptotes. Let's do the vertical asymptotes. Yeah. Now, how do we find vertical asymptotes? So vertical asymptotes, to find vertical asymptotes, you're looking for the x values so that the function is not defined. So in this case, it would be just root 3 and also positive root 3. Now, this is where you need the limit. So I need to compute the limit when x approaches root 3 from the left. And root 3 from the right. The same for negative root 3 from the left. And also root 3, negative root 3 from the right. They're going to be either positive infinity or negative infinity here. And how do we know which one is correct? Now, let's go back to the original function. So you have x cubed divided by x squared minus 3. I am going to write that as x cubed divided by x plus root 3 and x minus root 3. Right? Okay. Now, the first limit is, I want to find out what is the limit when x approaches root 3 from the left. So pick a number slightly smaller than root 3, and then come back to this. Slightly smaller than root 3, so it's still a positive number, which means the top is still positive. This guy is positive. This guy would be negative. So positive, positive, negative, you get a negative number. So negative infinity. The second limit, I'm approaching root 3 from the right. So pick a number that's slightly smaller than root 3. It's still a positive number, right? So the top is still positive. This is definitely positive. This is also positive because you're picking a number slightly bigger than root 3. So positive, positive, positive. This one is positive infinity. For this one, pick a number slightly smaller than negative root 3. Now it's a negative number. This is negative. This is negative because it's smaller than negative root 3. This would be negative as well. So negative, 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 you have negative number. And I'll let you check. The last one should be positive infinity. And so you have two vertical asymptotes, root 3 and negative root 3. And then the limit computations are here. The second thing, second type of asymptotes that we want to find is our horizontal asymptotes. That means we need to compute what is the limit when x approaches positive infinity and negative infinity. Good, we still have 16 minutes. Okay, so yeah, let's go ahead to compute that. Okay, so the original function was x cubed divided by x squared minus 3, right? So when it comes to a fraction of two polynomials, and when you want to compute x to positive infinity or negative infinity, we're only interested in the highest degree power. So you have the highest degree terms. So the highest degree terms here are x cubed for the top, and for the bottom it's just x squared. And so this is the same as computing the limit. Well, when you cancel out x squared, you get x, right? And what happens when we take x to infinity? Well, when you take x to infinity, x becomes infinity. Hope it makes sense. Similarly, for the second limit, this is negative infinity. So again, we only care about the highest degree terms. So the highest degree terms are x cubed for the top and x squared for the bottom, which simplifies to x. And so when you take x to negative infinity, x becomes negative infinity. Okay. The last type of asymptote I have is slant asymptote. Now, the original function was x cubed divided by x squared minus 3. And, well, this is exactly the same question that we did for slant asymptote. Yeah, if you go back to look at what we did here, so this is an example we did. You get that the slant asymptote is y equals x. So I'm gonna just write it down. Slant asymptote is y equals x. Now, what's next? Okay, so this is number 4. The next thing we want to find out is when is it increasing? When is a function increasing and when is it decreasing? And then we'll use that to find local max and local min. Okay, so how do we find local max and local min again? So you need to check. So local max and local min are, to find local max and local min, you need to set the first derivative to be 0. And the first derivative, you can verify that it's just this one. So I'm gonna just set this to be 0. So critical points are the points where the first derivative is 0 or undefined. Let me write this down. This is x f prime. Okay. Okay, so critical points are the points where the derivative is either 0 or undefined. Now, first of all, does it have any points where it's undefined? Well, if you say yes, then you are wrong. So you can see right away that it's undefined when x equals plus or minus root 3. But if you go back to the first part, we say that the domain is everything but plus or minus root 3. So it doesn't have any points where it's undefined. So no points, no undefined points. That means I only need to look at where is it 0. Again, the only way for a fraction to be 0 is when the top is 0. So this is the same as saying the top, which is x squared times x plus 3 times x minus 3 equals 0. You have 3 things multiplied to be 0, so you get x equals 0, x equals negative 3, and then the last term is x equals 3. So 3 candidates for local max and local min. And you want to check if they are in your domain or not. So 0, -3, and 3